We're going to try and solve some more questions. And let's talk about solving all questions related to alcohols. So, for example, this one. The question is: there's an apparatus below, and it was used with compound Z. A brick red precipitate formed in the right hand tube. So there's a Fellings reagent that's involved over here, as you can see. So Felling is reacting with this molecule. Now, where was Felling used in a reaction sequence? Felling was used not in reduction, but when you're trying to oxidize, and we were specifically trying to oxidize aldehydes to carboxylic acids. That is where Felling was used. So since over here there's a Felling reagent that's being used, we should know that it's used to oxidize. It's used to oxidize aldehydes. Uh, and he's saying that a brick red precipitate was formed, which means there's got to be an aldehyde over here. Ketones don't get oxidized, and I don't think he mentioned anything about potassium dichromate 6 changing color. I said, so what could compound Z be? Here's what type of alcohol is this? Can anyone guess what type of alcohol is this molecule over here? Primary, secondary, or tertiary? What type of alcohol is this?
Secondary.
Okay, that one is a secondary alcohol because there's a carbon chain, and the OH is right in the middle of the carbon chain. So it has two carbon chains, carbon atoms attached to it. So it's a secondary alcohols. And what do secondary alcohols change into? Secondary alcohols, as you can see over here, they change into ketones. So they're never going to react with Felling or with Tollens. So they won't have any reaction with Felling. So that means the first reaction is impossible. That Z is the first one. The other two are possible. These are both primary alcohols. Okay, so it's a carbon chain OH. So this is a primary alcohol, and this OH is also attached to one carbon chain. So this is also a primary alcohol. I said, remember this molecule over here. This is classified as a primary alcohol, although it doesn't even have a carbon chain. I mean, it has hydrogens on all sides. But this would be classified as a primary alcohol. So both of them, this second and the third one, are correct because they're going to turn into aldehydes, and these aldehydes would then further get oxidized to carboxylic acids. Is this clear, Mohammed? Is this clear? Isa, Ethan, is this clear?
Yep.
Yes.
Okay,
Yes.
then you have about oxidation. We're running out of questions related to oxidation. Just a second. The most So let's talk about this question now. Question number 18. So there's an alcohol with the molecular formula CnH2n plus 1, and it has a chiral carbon atom but does not react with KMnO4. So that means what type of alcohol is this? I mean, no oxidation is happening.
Oh, tertiary.
Okay, so that's a tertiary alcohol. Tertiary alcohols don't get oxidized. What's a tertiary alcohol? Tertiary alcohol is that you have an OH and there are carbon atoms or carbon chains on all sides, right? So that is what a tertiary alcohol is. But he then says that it has a chiral carbon atom. And he's asking you what is the least number of carbon atoms that such an alcohol could possess. So how can I make this chiral? I mean, what's a chiral carbon atom? How can I make this chiral?
Include
What's
another carbon at
hmm?
one of the bonds.
What's a chiral carbon atom when all four sides are different, right?
Yes.
So the only way I can make all four sides are as different, I can have two carbons over here and I can have three carbons over here. So now there's a chiral carbon atom, and he was asking for the least number of carbon atoms that such an alcohol could possess. So that is this molecule over here. So how many carbons does it have? It's going to have how many? 1, 2, 3, 4, 5, and 6 and 7. So 7 would be the answer. That you have a tertiary alcohol, and the second thing is it should be chiral as well, right? Somebody sent me a question like this. I think Mohammed, you sent me this
Yeah, I
question.
think I said what. Yeah.
Yeah. Okay, but that wasn't about alcohols. It was just probably, I think that in that question they were looking for an alkane, the least alkane with the least number of carbon atoms. So if you wanted to make an alkane chiral and have the least number of, so this carbon atom could have a hydrogen, it could have a carbon over here, it could have two carbons on this side, it could have three carbons on this side. So in that way, this carbon would become chiral. So in that case, again, it was 7 carbon atoms. You needed 7 carbon atoms minimum. Okay, then you have, so probably this one looks interesting. An alcohol of molecular formula C4H10O2 contains two OH groups. So remember, this is an alcohol, and it has two alcohols, and it has two OH groups. Now, on reaction with MnO4, which means oxidation, on oxidizing it, it is converted into a compound of molecular formula C4H6O4. So this is the oxidation product. So where are the OH groups attached? At what positions? So the first one, and it's an unbranched carbon chain, which means the carbon atoms, the 4 carbon atoms, are all in a straight line. So any guesses? Where would the OH groups be located in this molecule over here?
Would it be 1 and 4?
TK. And why would it be at 1 and 4?
Because it will form a carboxylic acid.
Exactly.
So yeah,
So both of the alcohols are going to be primary alcohols, right? It's going to be CH2 and this is going to be CH2. The reason they're going to be primary alcohols is that the number of oxygens will not increase. I mean, look at the number of oxygens. You have an alcohol, one oxygen. You have an aldehyde, again one oxygen. You have an alcohol, a secondary alcohol, one oxygen. You have a ketone, you have one oxygen. The only time the number of oxygens increases when you form a carboxylic acid. So since it was an alcohol, it must be a primary alcohol because otherwise, if it were a secondary alcohol, the number of oxygens would not increase. So that was the hint that the number of oxygens over here were 2 and over here there are 4 oxygens. So your number of oxygens are increasing. So that means both OH groups would be primary alcohols and that's only possible if they are at the ends. So it's going to be 1N, 1 and 4. So any other, so let's talk about this one. What is going to be the oxidation product of this molecule? Uh, and I think yeah, he's talking about reacting it with magnate 7 ions. Now, if you look at this molecule, the first thing that would happen is that it's an alcohol and it's also an alkene. So you must know the oxidation of alkenes. What happens in alkenes? That if you reacted with hot KMnO4 and hot concentrated KMnO4, if you reacted with hot concentrated KMnO4, the double bond is going to completely break and the molecule would break into two pieces. in the middle. And there were three scenarios. The three scenarios were, if you remember the three scenarios, that the double bonded carbon probably contains two hydrogens next to it. So that turns into a carbon dioxide and a water molecule. The second scenario was that the double bonded carbon had an R group and an H, a carbon chain on one side. That would change into an aldehyde and a carboxylic acid. And the third scenario was that the double bonded carbon had R on both sides, carbon chains on both sides. That would change into a ketone. So look at this molecule. It's going to be CH3, CH2, and CH. And the double bond has broken off at this point. Which one is it? First, second, or third? What would it change into?
The second.
TK, it's the second one. This one would change into a carboxylic acid. So this particular carbon atom would change into a carboxylic acid. TK, remember this is a carboxylic acid. This is the oxidation of alkenes. So it's either going to be C or it's going to be D. What about the other part? Now focus on the other part. It's going to be double bond CH, then it's CH2, and then it's CH2 and OH. Now this side, the left side is exactly the same. This side is the same. It's going to be a carboxylic acid. And the other side is a primary alcohol. So it's going to be CH2. And that would also change into C double bond O and OH. So this carbon atom and this carbon atom. One is the oxidation of alkenes that's happening. The other one is the oxidation of a primary alcohol. Isaac, you get this? Mohammed, Ethan?
Yes.
So, so C would be the answer. C would be the correct answer. Because I mean, this molecule over here is this one. Uh, so let's start with all the other reactions. TK, we've done some questions on oxidation and reduction. What's remaining is for alcohols, it's that alcohols are kind of acidic. So let's talk about alcohols being acidic. TK, just 1 second, let me open the board. Okay, alcohols are very weak, terrible acids, but they are acidic. They are capable of releasing H plus 1 ions. So alcohols are extremely weak acids. Now, what does that mean, extremely weak acids? And they have weaker ionization even compared to water. So even weaker ionization compared to water. Uh, you have CH3, CH2, and OH. There's a very tiny chance that the H at the end might break off. So it would result in the formation of CH3CH2 and O minus 1 ion. And the H plus 1 might break off. But the chances the ionization is even weaker compared to water. Water ionizes very badly. The amount of ions that water has is 1 into 10 to the minus 7 mole per dm cube. So that's really less. I mean, this is the ionization of water. Water is going to produce these many ions. That is the extent of the ionization of water. That's almost water not getting ionized in the first place. That's the quantity of H plus 1 that water produces. So water is a very bad acid or a base. I mean, because it's amphoteric, it produces both ions. It produces H plus 1 as well as OH ions. But alcohols are even weaker acids compared to water. Okay, so that number would just give you an idea how bad acids, how terribly bad as acids they are. And they won't have any acid reactions. Most of the time, they're not going to behave as acids. But they do lose the H plus 1 sometimes, which is why you classify them as very bad acids. This is ethanol, and here's your ethoxide molecule. Ethoxide ion, not molecule. So now the question is, why are they such bad acids? The reason there's such terrible acids is that carbon chains have an electron donating effect. Whenever you have a carbon chain attached to anything, it has an electron donating effect. What that does is that it increases the negative charge over here. So an alkyl chain next to the O, alkyl chains have electron donating effect. So alkyl chains have electron donating. Have electron donating effect, which increases the negative charge. Increases negative charge density on CH3, CH2O minus 1 ion. So the negative charge over here is pretty high because the alkyl chains are also pushing their electrons, which is why the negative charge is very, very strong. And if you have a very strong negative charge, the H plus 1 is not going to leave. It's going to come back. Hence, there's going to be less dissociation. Is this point clear? Mohammed, Ethan, Isa, is this clear?
Yes.
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 So that's the reason why alcohols are such bad acids. Uh, they only have one reaction. Usually they don't behave as acids. But they react with highly reactive sodium metals, group 1 metals. Reactive group 1. As a highly reactive group 1 metals. And the thing is, even with group 1 metals, they react with highly reactive group 1 metals very slowly. Like group 1 metals usually have very vigorous reactions, but with alcohols, they have very bad reactions. And the reaction is similar to how an acid would behave. Like if you have an alcohol and you react it with sodium metal, the sodium metal is going to come in and it would the H would be lost Like in HCl, the H is lost and Na takes over. So almost the same thing would happen. So it would be CH3, CH2O minus 1, and Na plus 1 would take over. And the H that is lost is going to produce a hydrogen gas molecule. So very slowly. So slight effervescence is seen in the reaction. Not a vigorous reaction, just a very, very slight effervescence that is happening during the reaction. Even with sodium, the reaction is very, very slow. Is this clear? ठीक है. Mohammed Ethan, is this clear?
Yep.
Is
Yeah.
there any like catalyst that can speed up the reaction?
I mean, usually in this case, no.
Okay.
ठीक है, that would be kind of not possible in this case.
Also, what's the use of the product?
No, over here.
Yeah.
I mean, there's no specific use for the product. It's just sorry, one second. What could happen is, but why would you want to do this reaction? Let's assume that why do you want to react an alcohol with sodium metal? The thing is, it would make the alcohol probably very water soluble. Like sodium salts are very soluble, and if you have an alcohol, like previously the alcohol was just polar. I mean, previously the alcohol had an OH group, right? So it was capable of forming hydrogen bonds, right? But now with the H lost, the H is gone. Okay, the hydrogen gas has gone away. Now there's an O minus for 9. Now the water molecules are going to be even strongly attracted. Right, Mohammed, is this clear?
Yep.
So adding sodium, actually remember this thing. Why do you want to add a group 1 or sodium compound? Because now ionic compounds, and especially group 1 ionic compounds, are very, very, I mean, they're kind of very soluble in water. So if you want to increase the solubility of a compound, any complicated compound, because most molecules, organic molecules, are not that simple. I mean, they don't have 2 carbon atoms. Most organic molecules are really, really big. They have 20 carbon atoms, they have 50. They could be polymers having OH groups. So by adding sodium, you can make the compound very, very soluble and water attracting at the same time. Now, the next thing we're going to try and do is esters. That alcohols do form esters. Esters are these fruity substances, and they're kind of oily liquids. They're not.
सर हम पास्ट पेपर साथ साथ सॉल्व करेंगे ना मतलब बाद में सारा खत्म होने के बाद नहीं करेंगे ना
उसके बाद भी करेंगे.
मैं अच्छा मतलब अगर कोई तब ज्वाइन करना चाहे तो कर सकता है
हाँ हाँ ठीक है वो भी.
मतलब पास्ट पेपर सेशन ना
हाँ वीकेंड पे तो वैसे ही हो रहा है.
ओके
ठीक है. अच्छा, so fruity sweet smelling oily liquids और esters में के अच्छा esters में कि you have an alcohol reacting with a carboxylic acid. अच्छा, just 1 minute, ठीक है. You have alcohols and carboxylic acids reacting to form ester and a water molecule. It's a condensation. I mean, this reaction is a condensation reaction, the forward one. And the backward one is a hydrolysis reaction. For condensation, the conditions are that you need a concentrated H2SO4 and you have to reflux. To break down an ester, you need to have a dilute acid or alkali, and you use reflux. So those are the conditions for this reaction. The way this reaction happens is you take an alcohol, any alcohol. It has OH groups, and you have a carboxylic acid at the other side. Now the H and the OH would be lost. They're going to be removed, and they would end up forming a water molecule. That's why it's called a condensation reaction. And the rest of the molecule the chain is going to link up. The reason this reaction happens in the first place is so the reason this reaction happens in the first place is that this oxygen over here has lone pairs, and the carbon over here has a partial positive charge. So the lone pairs of the oxygen are attracted to the positive carbon atom over here, which is why the H and OH eventually get repelled and they end up forming an ester molecule. So the two things they combine together, and it's going to be CH3. So it's going to be CH3, CH2, and then another CH2. Then there is O, and that O has now connected with the C double bond O on the other side, and it is CH2 and CH3. So the same as O levels. That's how esters are formed. TK, is this clear? Ethan, Mohammed, is this clear?
Yes.
And the way esters are named is, how do you name an ester? You name the ester in two parts. One side is going to be, you just count the number of carbon atoms. It's 3 carbon atoms. So this is prop. This other side is also prop because that side also has 3 carbon atoms. And then you give the suffix. The suffix for this is going to be, for the double bond O sides, the suffix is O8. And for the single bond O side, the suffix is propyl. So it's going to be propyl propanoate for this, the name of the molecule. And that's how esters are. That's how esters are going to be formed. And and you would be only asked to name simple esters. It's the IUPAC nomenclature doesn't really exist for esters which are more complicated. So they're given different generic names. They don't fit any naming system as such. So you can only be able to answer or name simple esters. Similarly, you can hydrolyze an ester molecule.
I have a question.
Yes.
For how is the oxygen attracted to the carbon?
No, because the oxygen has lone pairs, and the carbon over here is partial positive. Because it's a polar bond. CO bond is polar. The oxygen over here is electronegative. So it pulls the electrons away from the carbon, which makes the carbon partial positive. So that's how the oxygen gets attracted to this positive carbon atom. Ethan, is this clear?
All right, yeah, clear.
But at the same time, there's something else going on as well, and that is that's the concentrated sulfuric acid. Because the concentrated sulfuric acid is capable of attracting the H plus one and the OH ions both. Uh, it's a dehydrating agent, so it pulls the H and OH at the same time as well. But the mechanism is not that important. I mean, it's not important in this case. What you just need to know is why is this reaction happening.
All right.
The oxygen over here gets attracted to the positive carbon in the carboxylic acid. Now, hydrolysis of esters, the reverse, you're breaking down a molecule. Now, one thing about hydrolysis is that if you have an ester molecule, so if you have an ester molecule, the ester would break down in the middle. When you heat it with dilute acid or dilute alkali. Plus you're refluxing it. So when you heat it with dilute acid, it's going to break down. And this part would form the alcohol back again. It's going to become CH3O. The other side would become CH3, C double bond O. And there's going to be an OH attached over here, H attached over there, and an OH attached over here on the right side. So that's how your alcohol and your and a water molecule is going to get added to the ester. But the thing that you have to be very careful about is okay, so the thing that you have to be very careful about is that in alkaline hydrolysis, same thing happens in alkaline hydrolysis as well. You're going to lose marks for this if you don't do this. So hydrolysis, dilute acid, or reflux, or you could use dilute alkali plus reflux. But in alkaline hydrolysis, a carboxylic acid is never formed. A salt of the carboxylic acid is formed. The reason is that the alkali would react with the carboxylic acid, and that would result in the formation of a salt. So instead, you're going to get CH3. I mean, in this case, you're going to get CH3. And let's say the alkali was NaOH, so you will get a salt of the carboxylic acid. So is this clear, Mohammed Ethan? Is this clear?
Yes.
Okay, so this pretty much sums up the whole of the alcohol chapter that you have, and you have to be very careful with this because if they've given us NaOH and you're breaking down an ester using NaOH, never form a carboxylic acid. It's going to be the salt of the carboxylic acid, not the carboxylic acid. So, as the uses of esters, hopefully you already know where esters are used. Esters are used in perfumes and artificial food flavors. That's where you use esters. We talked about alcohols acting as weak acids, and we talked about reduction of all secondary alcohols and ketones and primary alcohols and aldehydes and carboxylic acids. We talked about the oxidation. We talked about the formation of alcohols. Okay, so we're pretty much done with the alcohols. Uh, the remaining is now very less is left. We're almost done with organic. Okay, probably tomorrow we'll be done with organic. We're left with aldehyde and ketones, and there's one nucleophilic addition reaction that has to be done. So is this clear?
Yep.
Try and go.
Yes, it's clear.
So try and go over the reactions. Then we'll start bigger questions. Right now we're just doing very short questions on organic because we haven't studied everything. Then we're going to start doing bigger questions on organic, which would include all the reactions. Okay? So let's continue tomorrow then. Okay, take care.
फिर ये recording भेज देंगे.
ठीक है मैं खुश. Okay.
Bye.
Sir,
Yes.
when are we gonna have our extra class?
The one that we missed.
Yeah.
When are you available? Like, how about tomorrow at let's say 11:15 or 11:30 Pakistan time. That would be 3 hours ahead. That's going to be probably 2:30 in Malaysia.
Oh, I still have classes.
Yeah.
When you get
AM?
hmm?
AM?
हाँ मतलब afternoon ना 2:30 PM.
नहीं आपने 11 बोला ना.
हाँ 11:30 AM. नहीं लेकिन
सर मेरे स्कूल जाना है.
अच्छा नहीं वो मैं डिस्कस कर लूँ पहले ठीक है. Ethan, can you send me your free time? ठीक है, your schedule. At what times are you?
Alright. Yep.
Then we can arrange that class.
Alright.
Okay.
Okay then. Message me, ठीक है? Send it on WhatsApp. Okay, take care.
Yep. Thank you.
Thank you.